All right, assalamu alaikum everyone. Let's begin. So in our last session, we did a few practice questions on sum to infinity. We discussed the idea of sum to infinity and convergence of a series. We also talked about that. So we talked about sum to infinity. We talked about convergence of a GP. And then we did a couple of questions after that. Now, today will be the last session that we spend on the AP and GP. And in this session, we are going to do some more practice questions. And then in our next session, we are going to move on to our next topic, inshallah. All right, so we are done with a few questions from the worksheet already. Now let's have a look at a few more. In today's class, let's start with this one, for instance. This is question number 28 from the worksheet. It basically involves something related to angles in a circle. Let's think about this. Although we haven't done circular measure yet, but I do assume that you already know some circular measure concepts from O levels as well, because mostly the concept was the same. So you would already know the stuff from O levels. Okay, let's begin with this. So, okay, so the first part does not involve circles actually. Let's have a look at the first part. First of all, it says in a geometric progression, so in a GP, all the terms are positive. Okay, so we're talking about a geometric progression, and in that progression, all the terms are positive. The second term is 24, and the fourth term is 13.5. We need to find the first term. So basically, first term is often denoted by the letter A. That is what we're looking for here. All right, now let me write down that information. So we have a GP. In this GP, we know that the second term, so that's T2, that is equal to 24. And we know that the fourth term, T4, that is 13 whole 1 over 2. We can say that's 13.5. That's the fourth term. So we have two specific terms given. Now, what's the term formula for a GP? It's given in the formula sheet. It looks like this. The term formula is AR raised to power n minus 1. What we can do is, we can find the second term using that formula. What would the second term be? AR raised to power n minus 1. So n is 2 in this case. So that's 2 minus 1. That should equal 24. All right. So T2 is AR raised to power 2 minus 1. Since we know that that is equal to 24, we can put this equal to 24. Similarly, what's T4? T4 would be AR raised to power 4 minus 1. That should equal 13.5. We have these two equations. We can find the value of A by solving these two equations simultaneously. Now let's look at the first equation. From the first equation, we get AR equal to 24. Now, since we need the first term, what we can do is we can make R the subject so that we could eliminate that. So R equals 24 over A. Now put this thing in the other equation, and that gives you, so originally you would have AR cube equal to 13.5 here. Now in place of R, you could input 24 over A. So that becomes A into 24 over A whole cube equal to 13.5. Now, if we simplify this, that gives us 24 cube over A square. Now, let me evaluate this. Let me actually simplify this a bit first. So we have A into 24 cube over A cube. That equals 13.5. Now, this A gets cancelled with one of these powers of A. So we have 24 cube over A square here. We could take A square on the right to the right side. That leaves us with 24 cube over 13.5 equal to a squared. And now we could take square root and get the value of a from that. Now remember, it says in the question that all the terms are positive. It means when we take square root here, we don't have to put plus minus. We generally always put plus minus whenever we are taking square root. But here, since we know that the value of a must be positive, we don't have to put plus minus here. So on the left side, we're actually getting 1024 from this. When you take square root of that, that gives us 32. So the first term, therefore, should be equal to 32. All right, that's the first part that we have. The first term turns out to be 32. Now let's look at the second part, part B. In part B, it says, so in fact, this was part A1, and then we have part A2. The second part says, find the sum to infinity of the progression. Now for that, we will need the ratio as well. So let's find the ratio. First of all, ratio is 24 over A, so that becomes 24 over 32, which simplifies to 3 over 4, or we can say 0.75. That's an exact decimal, so we can write that in decimal form, and that's okay. Now, this is the ratio that we have. You can just apply the sum to infinity formula. That's pretty straightforward. S infinity is equal to A over 1 minus R. The value of A is 32. 32 over 1 minus 0.75. And that is going to give you the sum to infinity of this geometric progression. Let's figure this out. This turns out to be 128. So the sum to infinity is 128. And that's what we were looking for in the second part. Again, that's pretty straightforward. All right, let's look at the next part now. In part B, it says, there's a circle that is divided into n sectors in such a way that the angles of the sectors are in arithmetic progression. The smallest two angles are 3 degrees and 5 degrees. Find the value of n. Now, how do we think about this? So the angles are in an arithmetic progression. So we have an AP that looks something like this. We know that the smallest angle is 3 degrees and then 5 degrees. So it's like this, 3, 5. Now, since it's an AP, arithmetic progression, that means the difference is going to remain constant. So the next term is 7, the next is 9, and so on. Now, the circle is divided into n sectors. We don't know what the value of n is. We need to find that value. Now, think about this. There are n sectors. The first sector has an angle of 3. The second sector has an angle of 5. The third sector has an angle of 7. The fourth sector has an angle of 9, and so on. Until we get to the last sector, we don't know what that sector number is. We could call that n or Tn. All right. So this is the first term, the second term. You could also write it like this. In fact, you could say this as T1 or A, T2, T3, T4. And then finally, you have Tn at the end, which we do not know what it is. All right. Now we have an AP. This is an AP, right? So we're looking for the value of n from this. Now think about it. This is an arithmetic progression. And these sectors are coming from a full circle. So if one angle is 3 degrees, the next angle is 5 degrees, the next after that is 7, and so on. What is going to be the sum of all angles in the circle? So we have 3, 5, 7, 9, and so on. It's a circle, right? So it's a full circle. You're dividing a full circle in sectors like this. So there's one sector like this. There's another sector that's slightly bigger. Then there's another that's slightly bigger than that. There's another that's even bigger, and so on. What's the total of all of these angles? The total of all the angles in a circle is 360 degrees. So if you were to add all of these terms, all of these n terms, the total would actually turn out to be 360. So what you have from that is Sn, the sum of all of these angles, sum of all of these n terms, that should actually equal 360 degrees. That's a piece of information that you have. Since these are sectors of the circle, of one single circle, the total angle in that circle is 360. So the sum of all of these angles should actually be 360 degrees. Now, keeping this in mind, what we can do is, since we know it's an AP, we know what the first term is. The first term is 3. We know what the difference is. We could just take any two consecutive terms and find the difference. We could say this is 5 minus 3, and that turns out to be 2. We could just use the sum formula and find the value of n from that. What's the sum formula for an arithmetic progression? There are two of them. Since we don't have the last term, we can use the one that has the first term and the difference, a and b. This is what the formula looks like. Half into n into 2 times a plus n minus 1 times the difference. This is sum of n terms. Now, since this is equal to 360, we can put this equal to 360 like this. Now, just input values of a and d in this. We could multiply this 2 on the other side. First of all, 2 goes to the other side. And on the right side, we're going to have 720. On the left, we have 2 into a, which is 3, plus n minus 1 times the difference. The difference is 2. On the right, we have 2 into 360, which is 720. Let's simplify this. We get n into 6 plus 2n minus 2, and that equals 720. Let's simplify this further. This is 4 plus 2n equal to 720. I'll have to simplify this, and this gives us 4n plus 2n square minus 720 equal to 0. 2n square plus 4n minus 720 equal to 0. We could simplify this. That becomes n square plus 2n minus 360 equal to 0. Now we could see if we could factorize this. Let's think about this. 3 factors of 360, 20 and 18. 20 into 20 is 400. 20 into 18 might work. So we could use 20 and 18. N square plus 20n minus 18n minus 360 equals 0. We get one factor, that is n into n, that's n plus 20. And the other is going to be n minus 18. So it's n minus 18 into n plus 20 equal to 0. That means either n equals 18 or n equals minus 20. Now, since the value of n cannot be negative, n represents the number of terms, we say this is not possible. So the only value of n that we have in this case is n equal to 18. This is our final answer here. All right, so sometimes you can have a situation given like this, which we would have to convert to a proper form, sequence. It could be arithmetic or geometric. In this case, it was arithmetic, and this is how we would deal with this. All right, let's have a look at another one. Let's try this. This is question number 6 from the worksheet. Let's think about this one. All right, so in the first part, we have to find the sum of all the integers between 100 and 400 that are divisible by 7. Now, let's think about that. What kind of sequence is this going to be? We're basically looking for multiples of 7 in this interval between 100 and 400. Now, let's start with the first number. What should be the first number? 100 is not divisible by 7. Let's think of the first factor of first multiple of 7 after 100. So 101 divided by 7 doesn't work. 102 doesn't work. 103 doesn't work. 105 eventually is going to work. 105 is a multiple of 7. So the sequence is actually going to start from 105. Then what about the next number? 112 119, and so on. So you can see what type of sequence this is. This is an arithmetic progression because the difference is constant. Let's write that down here. So we're talking about an AP. What about the last term? We could actually also figure out the last term. Just look at what is a multiple of 7 just before 400. So try 400 first of all. 400 is not divisible by 7. You could try 399. 399 over 7 works. That is giving you a value. So the last term of the sequence is actually going to be 399. So we also know that. We need to find the sum of all of these integers. So basically sum of all of this. Now remember the sum formulas that we have for an AP, both have an n in them. Let me copy the formulas here. So this is how the formulas are given in the formula sheet. It's an arithmetic regression. For an arithmetic regression, you need to know n to be able to find the sum, the number of values, right? So that's going to be important to know. For any formula that you use, you have the first term, you have the last term, the nth term, right? So we have this one and this one. We only need n now. If we are able to find n, we can just use the sum formula to find the total sum. How do you find the value of n now? Think about this. This is your first term, this is your second term, this is your third term, and this is your nth term. So we have an AP in which the first term, T1, is 1 of 5. What about the difference? Take any two consecutive terms. Next minus previous, you could say 112 minus 1 of 5, that is going to be 7. Now the term formula for an AP, what's that? That's a plus n minus 1 times the difference. We could just use that formula. We could say Tn or Un, doesn't really matter, equals a plus n minus 1 times the difference. This is the formula that we have for an AP. Now, if we apply this on this last term, we know that the value of the nth term is what? 399. So we could put 399 here. A is 1 of 5 plus n minus 1 times the difference. And this is going to give us the value of n. All right, so 399 minus 1 of 5, that would give us 294 equal to n minus 1 times 7. We could divide by 7 on the other side. And that is going to give us 42 equal to n minus 1. And the value of n from this turns out to be 43. All right, so we know what the number of values in this sequence is going to be now. Once we know the number of values in the sequence, now we can just apply the sum formula. We can use the one that has the last term because we know what the last term is. We need to find the sum of all of these terms, and we know what the last of these terms is. That's 399. Let's use that sum formula. We can say Sn equals half into n into a plus L. Remember what L used to mean? L means Tn, the nth term's value. Let's just input values here. We are looking for the sum of the 43 terms that we have in the sequence. We can say 1 over 2 times 43 multiplied by the first term. The first term in the sequence is 1 of 5 plus the last term. The last term in the sequence is 399. Just evaluate this, and this is going to give you the sum. 43 over 2 multiplied by 1 of 5 plus 399. And that gives me 10836. This is what the sum turns out to be in this case. That was the first part. All right, let's look at the second part now, part B. Part B says the first 3 terms in a GP. So now we're talking about a geometric progression. The first 3 terms are 144, x, and 64 respectively, where x is positive. Find the value of x. That's the first part. All right, so we have 144. So we have a GP, in fact. In this GP, the first term is 144. The next term is x, and the next term after that is 64. The first thing that we need to do is we need to find the value of x. That's the first part that's required. Now, how do you find the value of x in this? Remember, it's a geometric progression. So that means the ratio is going to be constant throughout. That means we could find the ratio by dividing the second term by the first term. That would be x over 144. We could also find the ratio by dividing the third term by the second term. That would be 64 over x. These two should actually be equal because both of these are giving you the ratio. We get one equation that's x over 144 that equals 64 over x. So second divided by first should be equal to 64 divided by x. We've discussed this before when we started geometric progression. That if you have three terms of a GP like this, A, B, C, B over A should equal C over B. All right, because the ratio remains constant. This is an equation that we have from this. X over 144 equals 64 over x. What you can do now is you can cross multiply, and that gives you x squared equal to 144 times 64. And that gives me 9216. Now we take square root. Again, remember, it says x is a positive number. Now, since x is a positive number, we're only going to take the positive square root here, not the negative square root here. All right. Otherwise, whenever you take square root, you have to put plus minus, right? So in general, you would put plus minus. In this case, we are specified that x cannot be negative. So we can just assume the positive value for this. X turns out to be 96 when we take square root here. This is what we were looking for in the first part. Let's look at the second part now. B2. It says find the sum to infinity of the progression. Now, what's the sum to infinity formula? It's a over 1 minus r. We already have the value of a, that is 144, divided by 1 minus r, and that's a problem. We do not know what r is. What we can do is we can just input value of x here, either here or here. That's going to give us the value of r. So we can say r equals x, which is 96 over 144. And that will give us a value, which is actually 2 over 3. So this ratio is 2 over 3. We could say 1 minus 2 over 3 here and see what the ratio turns out to be. 144 divided by this, that is going to give us 432. This is the sum to infinity of this progression. That was the last. Okay, I hope that makes sense. Any quick questions on this? So sum to infinity turns out to be 432. If there are no questions, let's move on to another problem. This is question number 6. Let's try another one now. Let's see what else we could try from this. All right, let's try this. This is question number 11 from the worksheet. Okay, so now this says the first term of an AP is 8 and the common difference is D. So first term of an AP is 8. The common difference is D, where D is not equal to 0. The first term, the fifth term, and the eighth term of this arithmetic progression are the first term, the second term, and the third term, respectively, of a GP, whose common ratios are. Write down two equations connecting DNR, hence show that R equals 3 over 4, and also find the value of D. Let's think about this now. So we know that there's an AP. First of all, there's an arithmetic progression. In that arithmetic progression, the first term is 8. So A is 8. That's one thing that we're given. And the difference is just D. And then we know some relation between some terms of this AP and another GP. Let's write that information down here. So first of all, we have an AP. For the AP, we are looking at the first term. Okay, and the fifth terms, that's T5, and the eighth term. For the GP, we are looking at the first three terms, so that's T1, T2, and T3. These are the three values that we're looking for in each sequence. And remember what the term formulas are for AP and GP. For an AP, Tn is equal to A plus n minus 1 times the difference. And for a GP, it's Tn equals AR raised to power n minus 1. They're given in the formula sheet as well. In case you forget, you can refer to that formula sheet. Now, what does it say? The first term of the AP is 8. So we know that this term is 8. And the first term of the GP is also the same. So this should also be 8. All right. Now the fifth term here is equal to the second term here. We don't know what those terms actually are. And the eighth term here is equal to the third term here. What we can do is we can write down, first of all, the fifth term and the eighth term of the AP. How do we do that? We have the term formula. We know the first term. The first term is 8. So if we're looking for the fifth term, what would that be? A is 8. So that gives us 8 plus n minus 1. N is 5. 5 minus 1 is 4 times the difference. That's the fifth term here. And what about the eighth term? Again, we know what the first term is. That's 8 plus n minus 1. N is 8 here. That's 7. 8 minus 1 times the difference. This is the eighth term of the AP. Now, similarly, we could write down the second and third terms of the GP as well. If the first term is 8, what about the second term? 8 into r raised to power 2 minus 1, which is just 8r. And then 8 into r raised to power 3 minus 1, which is just 8r squared. And now we could make two equations from this. We could say, since this fifth term is equal to this 8r, they should be equal. So we can put them equal. And similarly, 8 plus 7d, that is equal to 8r squared, and that's going to give you another equation in terms of d and r. So that's what it said. Write down two equations connecting d and r. We have two equations here. The first equation is 8 plus 4d equals 8r. And the second equation is 8 plus 7d equals 8r squared. Now from the first equation, what do we get? We get 2 plus d equal to 2r. We could make any one of these variables a subject. We could make d the subject, for instance. If we make d the subject, that gives us 2r minus 2. I can go and input this value in the other equation. That gives us 8 plus 7 into 2r minus 2 equal to 8r squared. Now we have one equation and only one unknown. We can figure out this value. So this is 8 plus 14r minus 14 equals 8r squared. And this is going to become 8r squared minus 14r. You have minus 6 on this side, it goes to the other side and becomes plus 6 equal to 0. We could simplify this, which gives us 3r squared minus 7r plus 3 equal to 0. And in this equation now, we could use quadratic formula, or we could do the middle term breaking thing. You can do whatever you prefer. Can we break the middle term? Let's think about it. 3 into 3 is 9. We could get 9 by 4, 3. That's not quite going to work. I have to check my working a lot of times. This does get factorized. Maybe I've done some calculation wrong here. Just to recheck, maybe it's right. Let's just quickly check. This is minus 6. It goes to the other side, becomes plus 6. 3, 7. No, yeah. So when we divide by 3, it actually when we divide by 2, it actually becomes 4r squared and not 8r squared, not 3r squared. I wrote that as 3 by mistake. So this is 4r squared minus 7r plus 3. Now, can we do the middle term breaking now? 4 times 3, that is 12. We could get 12 by 4 and 3. Yeah. So we could factorize this. We could say this is 4r squared minus 4r minus 3r plus 3 equal to 0. We get two factors from that, 4r minus 3 and r minus 1. That means either r equals 3 over 4 or r equals 1. Okay. These are the values of r and d that we're getting. It says show that r equals 3 over 4. We only have one value of r given there. That's 3 over 4. Okay, let's actually find the corresponding value of d first. It says also find the value of d. Now, if you were to find the value of d using both of these values of r, for the first value, we get d equals 2r minus 2, which is 3 over 4 minus 2, and that gives us 3 over 2 minus 2, which is minus 1 over 2, minus 0.5. If we put the other value here, that gives us d equal to 2 times 1 minus 2, which is 0. We know in the question it says d cannot be 0. Because think about it, if d was 0, the difference was 0, the same value will just keep getting repeated. So that would not make sense, right? So you'll have the same value repeating again and again. So 8 will just keep repeating itself. And the same is true if the ratio was 1 in the geometric progression, the same value would just keep on repeating. They have specified that difference cannot be 0. If difference cannot be 0, that means ratio of the GP can also not be equal to 1. So we ignore these values. We say this is not possible because it's given in the question that it's not. And we have this value of r, which is 3 over 4, and this value of d, minus 0.5, which are the two valid answers of this equation, of this part. Okay, that was the first part. Let's look at the next part now. In the next part, it says, find the sum to infinity of the GP. That's relatively straightforward. Sum to infinity formula is just a over 1 minus r. We know what the first term is. For the GP, it's 8. We've also found the ratio. Ratio is 3 over 4. So this is pretty straightforward. This turns out to be 32. All right, that was the second part. In the last part, it says, find the sum of the first 8 terms of the arithmetic progression. Now for this, we could just use the sum formula for an AP. Sn equals half n into 2 times a plus n minus 1 times the difference. This is the sum formula for an AP. Now let's just input n equal to 8 because we're looking for S8. Sum of the first 8 terms. So in place of n, we could input 8. This multiplied by 2 times a. The first term is also 8 plus n minus 1, which means 7. 8 minus 1 is 7. Into the difference that we found here was minus 0.5. Just evaluate this and see what you get from this. It's half into 8 into 2 into 8 plus 7 into minus 5 minus 0.5. This turns out to be 50. This is the sum of the first 8 terms. All right. That is what we were looking for in the last part here. Let me know if there are any quick questions. Otherwise, we just do one more question from a recent paper. And then we end for today. In the next class, we will start our next topic, which will be most likely circular measure, but I confirm that. Let's have a look at this question for now. So I've taken this from a recent paper because this has this concept of convergent sequence as well. Let's have a look at this. Okay, so the first part, it says the first, second, and third terms of a GP are 3K. So we have a geometric progression. It's a GP. The first 3 terms are 3K, 5K minus 6, and 6K minus 4. Show that K satisfies this equation. Now, remember what I said for terms like this. If you have 3 consecutive terms, how can you relate them? You could find the ratio using the first 2 terms. You could say the ratio of this GP is equal to 5K minus 6 divided by 3K. Second term divided by the first term. And that is also equal to 6K minus 4 divided by 5K minus 6. So that's the third term divided by second term. That also gives you the ratio. Now, this is an equation that you're getting. Now, just cross multiply in this equation. You get 5K minus 6 whole squared. On the other side, you have 3K into 6K minus 4. Let's simplify this. On the left side, we have A minus B whole square, which is A square. That's 25K square. Minus 2 into 5K into 6. That is going to give us 60K plus 6 squared, which is 36. On the right side, we have 18K square minus 12K. Take everything to the left side. That gives us 7K square minus 48K plus 36 equal to 0. And that's exactly what we had to show here. 7K square minus 48K plus 36 equal to 0. In the second part, it says, showing all necessary working, find the exact values of the common ratio corresponding to each of the possible values of K. So we need to find ratio for each of the possible values of K. So you have to first find the possible values of K. You have a quadratic equation. So remember, you have to show the process, show the working. Otherwise, we won't get marks for solving a quadratic equation. You always have to show working. You either show the midterm breaking process or you put values in the quadratic formula. Now, now let me try to think about this. Can we factorize this? 36 into 7, that gives me 252. Let's see how we can get 252. 50 into, no, we have to be adding. 40 into 8, that is 320. Okay, so 41 into 7, that's not all. 42 into 6. Yeah, 42 into 6 works. So we could say this is 7K square minus 42K minus 6K plus 36 equals 0. Alternatively, you could just input values in the quadratic formula and that will give you the same thing as well. Now we could take, that will give you the values of K as well. That's okay. If we take 7K common here, that leaves us with K minus 6 in the brackets. We could take minus 6 common here, and that leaves us with K minus 6 in the brackets as well. We get one factor, which is 7K minus 6, and the other, which is K minus 6. So that means k either equals 6 over 7 or k equals 6. Now, what's the ratio? It says find the exact values of the common ratio. We have these two possibilities for finding ratio. We could either input values in this fraction or this fraction. That's our choice. We could input those values of k in any one of these fractions. So let's use the first one for instance. That's relatively easy to calculate. R equals 5k minus 6 over 3k. Let's just input each of these values one by one. So if we input k equals 6 over 7, let's see what we get from that, and also see what happens if we input k equals 6. So this is going to be 5 into 6 over 7 minus 6 divided by 3 into 6 over 7. Now, since it says showing all necessary working, find the exact values, that means you have to show working and you also have to write exact values. You have to show some working at least. What you can do here in this case is you can just find the numerator from a calculator first of all. That gives you 5 into 6 divided by 7 minus 6, which is minus 12 over 7. That's what you have in the numerator. Do the same thing in the denominator. That's going to be 18 over 7. 7 and 7 get cancelled, and we're left with minus 12 over 18, which turns out to be minus 2 over 3. This is one possible value of the ratio here. All right. Let's look at the other possible value of the ratio. If we input k equals 6 there, that is going to give us r equal to 5 into 6 minus 6 divided by 3 into 6. In the numerator, you have 24. In the denominator, you have 18. And that gives you 4 over 3. You don't write this in decimals. Just leave it like this in the form of a fraction. So we have two values of r which are possible here, minus 2 over 3 or 4 over 3. These are two possible values of r that we get from this. Okay, let's move on. In the last part, it says one of these ratios gives a progression which is convergent. Find the sum to infinity. Remember what a convergent sequence is? We did this the other day. A series converges if this condition is met. The same condition that we have for sum to infinity. Ratio should be between minus 1 and 1. All right, so convergent means ratio has to be between minus 1 and 1. That's what convergence means. That's the condition for convergence, because if the ratio is between minus 1 and 1, the sequence would eventually converge to 0. Right? The values will keep getting smaller and smaller, and they'll become 0 eventually. Now, we have two answers here from the last part, which are telling us either r could be minus 2 over 3 or it could be 4 over 3. Now, which one of this falls in the range, in the interval for r? So for the series to be convergent, ratio should be between minus 1 and 1. Which of these ratios satisfies that condition? This one is bigger than 1, right? This is bigger than 1, so this is outside the range. The first one does fall in the range, so that means the ratio that we take should be r equals minus 2 over 3. Now, using that ratio, we just need to find the sum to infinity. Now, the sum to infinity formula requires two things. A, that's the first term, and r, we know the value of r. What about the first term? We need to find the first term now. The first term was 3 times k, so we need to figure that out. A equals 3k, but where does this value of k come from? You use the value of k that is giving you this ratio. So which value of k is this coming from? Is coming from k equal to 6/7. Let's input that here. So it's 3 into 6/7, and that is 18/7. This is the first term. And just input values in the formula. A is 18/7 divided by 1 minus 2/3. So that becomes 18/7 divided by 1 plus 2/3, which is 5/3. Now we need to find the sum to infinity. It doesn't specify whether you want an exact answer or not, but it's still better to give an exact answer. Just evaluate this on a calculator. You'll get that 18 divided by 7 into 3 divided by 5, and that is giving me 54/35. So the sum to infinity therefore turns out to be 54/35. This is what we were looking for.